All right, so we're going to take a look at how do I write a piecewise function from a graph. So from the previous video, we talked about what a piecewise means, right? So piecewise different parts. So let's do this first part. X plus 2 looks like this whole line, but it has a domain restriction, meaning we're only looking at this box. All right, we have y equals 1, so the line y equals 1 looks like that. And again, we have a domain restriction, so we're only looking between -1 and +1. Then the last one, we have x squared, so it looks like that, but we're looking only at where x is greater or equal to 1. So we're only looking in these boxes. So when you take these three individual graphs and you put them together, you're going to have that one is the first one. Then you're going to have this little piece of a horizontal line. And then you're going to have for x is greater or equal to 1, the quadratic. Now, completely assemble that graph, it looks like this. So this is your piecewise function. It's made of 3 separate graphs. All right. In your Desmos calculator, this is how you would put it in, just like that. I'm going to write down the f of x. You don't put that in Desmos, but you put that in just like that. That would represent those 3. However, it doesn't necessarily mean that you're going to have this calculator on your test. So let's do this by hand. You're going to write this equation down. So again, break it down into pieces. So what pieces do you see? I see a quadratic. So here's part of a quadratic. Then what's my domain restriction? So it's only there. That's where the quadratic exists. Then I see a sloped line, which is from here, and again, mark your domain restrictions. So here's some notes for you. So straight lines are y equals mx plus b. This should just be a quick review. A quadratic, you're going to have it, you could have it in standard form, which is y equals ax squared plus bx plus c. But since we've done transformations, we're going to stick with vertex. All right, so my domain restriction happens at 1. So less than 1 is quadratic, greater than 1 it is linear. So if you remember from parent graphs, right, when you have a quadratic function, it goes 1, 1, and then it goes 2, 4 on both sides. And I'm just actually going to quickly show you that because maybe you can't see it because I can see it's moved left and down. But look at a parent graph, right? So you see 1 squared is 1, -1 squared is also 1. 2 squared is 4, -2 squared is also 4. So if you look at the pattern, it goes 1, 1, and then 2, 4 on both sides. 1, 1, 2, 4. So let's go ahead and do it here. For that vertex, 1, 1, and then 2, 4, you can see is another coordinate. That means that this is the original parent graph, but all that's happened, it's moved left 1 and down 3. Well, how do I write that? How do I write it's moved left 1 and down 3? So remember, inside is x and opposite, outside is y and regular. So start off by writing what should be inside. Left 1, how do I say that? +1. And then down to -2. For the other line, go ahead and extend it so we can write the equation down. So what's my slope? So 1 point to the other is +2, -1. So 2 over -1 is -2x. And where does it cross the x-axis? At 3. So that's +3. All right, so now I've written them down. I need the restriction. So x must be less than 1. And here, x must be greater or equal to 1 because there is a defined dot right there. And it doesn't matter if you say x is less than or equal to 1 and then x is strictly greater than 1, whichever method works. So let's go ahead and write these two down. So I've got the first one, which is x plus 1 squared minus 2 with the restriction of x less than 1. And then the second one is I have -2x plus 3 with the restriction of x must be greater or equal to 1. All right, is it continuous? So that means, do I have any breaks? I don't have any breaks, so yes, it is continuous. If you were given the Desmos calculator, you can use the squiggly line instead of the equal sign, and x1 anytime you see x. So you'd write down the whole equation. Instead of the equal sign, put the squiggly line, and instead of x, you'd put x1, and for both equations. All right, let's take a look at one more example to make sure you got this. So again, I can see 3 parts of this piecewise function. So here's part 1 with the domain. Here's part 2 with the domain. And here's part 3 with the domain. I'll start off by writing the domain instructions first because that's simpler. So it starts at -3, then 0, right? So this is less than or equal to -3. And then here, because they're both open, it's strictly less than. So x lies between -3 and 0, strictly less than. And then finally, you have greater than or equal to, because it's a solid dot, 0. So remember, when you have a horizontal line, it's going to be y equals. If you have a vertical line, it's going to be x equals. So this is y equals -2. All right, this is a slanted line, which means it has a slope. This is y equals mx plus b. So what is the slope? I'm going to go down 1, right 1. So that's -1 over +1, which is -x, and it crosses at +4. This is a straight line again, so y equals mx plus b. What's my slope from one point to another? Up 1, right 1. So 1 divided by 1 is x. And then where does it cross? +0. So it simplifies to y equals x. So I have my 3 lines with my 3 restrictions. So let's go ahead and write it down. The first one is -2, and my restriction is x is less than or equal to -3. My second one is -x plus 4 with my restriction between -3 and 0, strictly less than. And my last one is x with my restriction being x is greater than or equal to 0. Is it continuous? Okay, so if it's continuous, you don't pick up your pen. But if it is not continuous, you pick up your pen. So you see in this example, I don't pick up my pen continuous. Here, I'm picking up my pen to go to the next line, picking up my pen to go to the last line, so it's not continuous. All right, so that's how you write equations, piecewise equations. Let's practice.